when we make measurements in science, or when we may do calculations that are based on measurements, we're interested in knowing how well we did. And so here are some words that are going to describe those things for us. Going to tell us whether we did a good job, or ways in which we can explain whether we did a good job in measuring or not. So accuracy and precision are words that in our everyday lives we might use interchangeably, but in science class, for the purposes of describing measurements, they have different definitions. So let's talk about accuracy first. So accuracy tells us how close a single measurement came to the expected value. Now the expected value might be something that we already knew about, that we looked up, or something that we calculated ought to be the correct measurement. And so we can tell the accuracy of a single measurement. We just have to measure once, compare it to what we expected, to tell if we did a good job of measuring, or our experiment went well, or if it didn't go very well. Precision is something different. Precision is how close a series of measurements, and by series we mean two or more measurements, how close they came to one another. So precision doesn't, in this context, doesn't have anything to do with whether the measurement was right or wrong. It's only if we measured twice, did we get pretty close to the same answer each time. If we measured 3 times, did we come pretty close? All right, so those are words there. Now let's think about how we can maybe describe that a little better in terms that we can understand a little better. So here's a target. We can imagine that this is on a dartboard, and we're going to throw, actually we're not really going to throw darts at it, we're going to have pictures of darts come onto this target. And our goal here is to hit the center of the target. Not all dart games are like this, but in this case we want to hit the center of the target. So we throw a dart, hits the center of the target, and we could say that was an accurate throw. So we throw another dart, hit the center of the target again. We can also say that this throw was an accurate throw. We throw the dart, we hit the center of the target again, and we can say that this third throw was an accurate throw. So each one of these throws is accurate. As a group, altogether, they're precise because they all came very close to one another. Let's look at another example. Here's our target again. We throw a dart, we miss the bullseye. So we can say that this is not a very accurate throw. We throw another dart, and again we miss the bullseye. Also, not a very accurate throw. And we throw yet another dart, we miss the bullseye by a little way. So again, not a very accurate throw. So we've had each one of these throws is not very accurate. And as a group, looking at them all together, they're not very precise because they didn't land very close to each other. So these are not accurate as individual throws, and as a group, they're not precise. How about one more example? Here's our target. We throw a dart, miss the target, an inaccurate throw. We throw another dart. Again, we miss the target, also inaccurate. We throw a third one. Again, we miss the bullseye, not an accurate throw, but as a group, these throws are very precise because they all landed very close to one another. So accuracy and precision are different things. Accuracy measures the result from a single attempt at measurement, and the precision sums up the results from a group of measurements. All right, what about this case? One dart, second dart, third dart. So in this case, we would say that throw number 1 was accurate. This is accurate. And this is inaccurate. We missed the bullseye. And over here, this one is also inaccurate. And what do we say about them as a group? as a group, they are not precise, or they're imprecise because they didn't land all together. So we see different levels of accuracy for the individual throws, but for the group, we have one level of precision, which is not a very good level of precision. All right, so what can we do about this, or how can we report this information? So when we're talking about accuracy, we can use the idea of error to say just how accurate we were. With the darts, we were saying, well, accurate, not accurate, but we can actually put some numbers on that, and we can do that by calculating error. So error is the difference between the experimental value, what we actually got when we made a measurement or made a calculation based on measurements, and it's the difference between the experimental value of a measurement and the expected value. What did we expect to get when we measured something? So here's how we can sum it up into a little formula. The experimental value minus the actual value. So the experimental value is what we get when we do the measurement. The actual value might be something we looked up or something that we expected to get based on calculations. We have some idea that this is what we should get. So we can use a little example. I've got a note here, a golf ball. Let's talk about a golf ball now. So a golf ball, I don't have a picture of a golf ball, but you can picture a golf ball in your mind. And it's supposed to be 42.67 millimeters in diameter. So let's suppose that we did a measurement. We took a golf ball, we measured it with whatever device we had, and we found out that our experimental value, when we measured it, was 43.00 millimeters. Okay? So this was our expected value, or our actual value, what we know should be the answer. And this was what we got, was our experimental value. It's what we got when we actually made the measurement. Is this a good measurement or not? We can tell by subtracting. So our error in this measurement is 43.00 millimeters minus 42.67 millimeters. And so our error is 0.33 millimeters. So this is our error in this particular measurement. So we put a number on it. And we might have to have some experience to tell whether that's good or bad. But now we have a number. All right, what if we had made our measurement and found that our experimental value was bigger than our accepted value or our actual value? And then when we did the subtraction, we would have gotten a negative number. Well, we can take care of that by putting these little lines in the formula. And these lines denote absolute value. So some books will actually tell you that you should subtract experimental value from actual value to get error. And we're going to take care of that contradiction by saying it doesn't matter which one you subtract from which other one. We're always going to take the absolute value. We're always going to get a positive number for error. Not everybody does it this way, but we will do it that way. So number is the absolute value of experimental value minus actual value. In other words, error is always positive. That's our view of the world here. All right, what can we do with the error? Is the error a lot or a little? Here's one way to calculate that. If we take the error, the difference between what we measured and what we should have gotten, and divide it by the actual value, then multiply that by 100%, we can figure out the percent error. And percent error tells us, is another way of giving us an indication of whether we're close or not so close. So with our golf ball, we had an error of 0.33 millimeters. We can divide that by the actual value, what we expected to get, 42.67 millimeters, and multiply that by 100%. And when we do that, we're going to find out that we've got quite a small error. So here's a formula for the percent error. Experimental minus actual over actual times 100%. So this is this rewritten in another way. Okay? All right. So now we've got some ways that we can describe our measurements. Was a single measurement accurate? Was a group of measurements precise? And if something was accurate or not accurate, we can put some numbers on it to describe and help us compare from experiment to experiment. One more point, and that is error is not bad. Okay, there are some things we need to be right about, and if we're not right about them, that's going to cause us a problem. But when we do an experiment and we get an error, it's not because our experiment is bad, or we don't have to feel bad about that. The error helps us explain what happened, and it helps us to see if our experiment went as expected, and if we maybe didn't account or didn't consider something that happened. So an error can tell us things that will help us. So error is not always bad.